Now that we've spent a few days studying parallelograms, today we're going to extend our discussion to include some special parallelograms, namely the rectangle and the rhombus. Now we're going to define a rectangle to be a quadrilateral with 4 right angles. Because all rectangles are automatically parallelograms, namely they have 2 pairs of parallel opposite sides, the rectangle has all of the properties that you've gotten used to working with respect to the parallelogram. In addition to all those properties, the rectangle has a little something extra going for it, and that is that it has congruent diagonals. So if we take a look at the picture here on this page in your notes, if I were to go to label the vertices of this rectangle, remember that when I label vertices of any polygon, I either have to go around in a clockwise motion or a counterclockwise motion. And regardless of how or which direction I choose to go, vertex A and C will always be opposites, as will vertices D and B. So by saying the rectangle has congruent diagonals, we're really saying that line segment AC is congruent to line segment BD. All right, like the rectangle, a rhombus is also a parallelogram, but by definition, we're going to say that a rhombus is any quadrilateral with 4 congruent sides. Because the rhombus is a parallelogram, it has all of the properties that go along with the parallelogram. And like the rectangle, it has a little something extra going on for it. The first something extra that you have to remember about the rhombus is that its diagonals are perpendicular. The second something extra that you have to remember about the rhombus is that its diagonals bisect pairs of opposite angles. So if we take a look at what that means in terms of a picture, it means that the diagonals in the rhombus are always going to form right angles. So all of the angles that are formed by the diagonals will be right angles. And because the diagonals bisect opposite angles, these 2 pairs of angles in opposite corners of the rhombus will always be congruent. All right, let's go ahead and see how we can use these new properties in solving some problems. In example 1, they tell us that we're given rectangle ABCD with the given diagonals intersecting at point E. They tell us the lengths of some line segments, and they want us to find the length of segment BD. So like always, the very first thing I'm going to do in my approach is draw a nice big diagram. And again, when I label my vertices, I'm either going to move around in a clockwise fashion or in a counterclockwise fashion. And regardless of my approach, A and C will always be opposite vertices, as will be B and D. These 2 diagonals intersect at point E. And I'm going to go now and label the segments that were given to me. So A to E is 10x plus 20. C to E is negative 4x plus 76. And they want us to find the length of diagonal BD. Now, because a rectangle is a parallelogram, I know that the diagonals bisect each other. So I know that the distance from A to E is the same as the distance from E to C. And likewise, I know that the distance from B to E is the same as the distance from E to D. Using the information that was given to me, because I have 2 segments that are congruent, I can go ahead and set their measures equal to each other. I'm going to go ahead and start off by saying 10x plus 20 equals negative 4x plus 76. And there are a variety of different methods you can use to solve this equation. You're all good equation solvers at this point. So if you choose to solve a little bit differently than I do, but still come up with the same answer, you'll know that your method of solution was indeed correct. So I came up with x equals 4. So what that means is that the distance from A to E is going to be 10 times 4 plus 20, or in other words, 60. The distance from E to C is going to be negative 4 times 4 plus 76, which is also 60. And these 2 came out exactly the same, which is what I would expect because I want those diagonals to bisect each other. So now I know if the 2 pieces are 60 and 60, I know that the length of the entire diagonal has to be 120. And because this parallelogram happens to be a rectangle, and I know that in the rectangle the diagonals are congruent, I know that if one diagonal has a length of 120, I know that the second diagonal, diagonal BC, must have a length of 120 as well. All right, so that's how you might use that first property in solving a problem. The second example has us taking a look at a rhombus. It says, in simplest radical form, find the perimeter of a rhombus whose diagonals are 12 and 18 inches. So my approach is still the same. I'm still going to go ahead and start by drawing a picture. This guy is a rhombus, which means that all of his sides are congruent to each other. And I know that the length of the entire diagonals are 12 and 18. Because a rhombus is a parallelogram, I know that the diagonals bisect each other. So if the first diagonal measures 12 inches, I know that the two pieces, or the two parts of those diagonals, are 6 and 6. And that's what I'm going to go ahead and label in my picture, because it's going to be pretty tough to label that picture with the entire diagonal of 12. Likewise, for the longer of the two diagonals, the entire length is 18, but because it was bisected, I know that each piece has to measure 9. The other thing that I need to recall is that for a rhombus, the diagonals are always perpendicular. So those diagonals are going to form right angles. In order to find the perimeter of this fella, I need to know the lengths of all his sides. Well, I know that they're all the same. I don't have a numerical value for those sides at this point. But what I do have is I have these 4 beautiful right triangles. Each of these right triangles are the same. And in each of these right triangles, I know the sides of the two, or the length of the two legs, but I don't know the length of the hypotenuse. I can find the length of the hypotenuse by utilizing the Pythagorean theorem. So 6 squared plus 9 squared is equal to x squared. I'm going to go ahead and put this into my calculator, and when I enter 6 squared plus 9 squared into my calculator, I'm told that that is equal to 117. When I take the square root of both sides, I have to remember to take both a positive and a negative square root. However, since I'm dealing with length in this particular question, I can't have negative length. And I know that the length of each side is now the square root of 117. Note that in this question, they don't specify whether to leave it in simplest radical form or round to some specific decimal place. And because we're not asked to round, we're automatically going to leave that number in simplest radical form. Square root of 117, I can't get to simplify. So I'm going to say the length of each side is equal to the square root of 117. So the perimeter of my rhombus is going to be root 117 plus root 117 plus root 117 plus root 117, or in other words, 4 times the square root of 117. And I'm going to label this with the dimension since they were given to me, or with the units since they were given to me in the problem. 4 times the square root of 117 inches. All right, in the last question, this problem too is also dealing with a rhombus. They tell me that I'm given this rhombus ABCD, and once again they're talking about the diagonals. So I'm going to go ahead and sketch a picture. And the point at which these two diagonals intersect, they've told us, has to be point E. They tell us that the measure of angle DAC has to be 18 degrees. So this little guy in here is 18 degrees. And they want us to find the measure of angle ABC. So ABC is that guy up here. Well, I'm going to use a few of the properties that I know about a rhombus and some properties that deal with triangles as well. I'm going to start off by looking at that little yellow triangle. I know that because my figure is a rhombus, that side AD and side DC of that triangle are congruent to each other. And that tells me that the two base angles of that triangle must also be congruent to each other. So now I've got a triangle where I know 2 out of the 3 angles I can simply subtract from 180, and it'll tell me the measure of angle, or that angle in the lower left-hand corner. So the measure of angle ADC has to be 144 degrees. Because every rhombus is also a parallelogram, I know that the opposite angles have to be congruent. So if the measure of angle ADC is 144 degrees, the measure of angle ABC must be 144 degrees as well. So you can see in looking at both examples 2 and 3, even though we're living in the world of the quadrilateral at this point, we still used a lot of the properties of triangles in order to solve these questions. And that's going to be an important thing to remember in moving forward. All right, at this point, I'm going to have you summarize the key ideas and important takeaways that you need to recall from this video, and then go ahead and see if you can apply what you've learned to solve the questions on that next page in your notes.